everyone, it's Adrian from Audio Excellence Canada. Today I'm really delighted to have joined with us three people from Audioquest. There's Garth Powell, he's head of engineering at Audioquest. Fred, who is my direct agent with Audioquest. He works directly with Audioquest. And then Isaac, who I'm meeting for the first time today. And apparently, Isaac, do you rep in Canada or US or worldwide?
I'm the ambassador for aspirational audio, and I do a limited number of accounts across the United States from East Coast to West Coast. And then I support through the education team, and when I have the privilege of working with Garth, answer questions and things like that. And so those questions extend beyond those borders, but I work in the United States primarily.
Let's start with my one pet peeve with Audioquest, and Fred knows this. You guys have the worst names, like seriously, the worst names for your SKUs. I can never, to this day, how long have I been a dealer now? 5 years? I still don't know. 7 years. I still don't know which models are higher than the others. I always have to go back to the price sheet. Now, is earth more expensive than water? Is water more expensive than earth? You know, director of aspirational, what was your title again?
Ambassador for aspirational
Ambassador.
audio.
Wow. Did you pick up that title for yourself, or did Fred give it to you?
It was generously bequeathed upon me. We work in an organization that believes language is very powerful, and so we spend a lot of time thinking about names. It's interesting over the years, because I had the privilege of working in retail and managing a larger retail custom integrator hi-fi shop, and customers learned about the names of their products before us, which was really fascinating. And so customers would come and go, I have an entire system of cinnamon. And it's like, you'd have to go to the wall and be like, okay, where is that? You're like, oh, that's really awesome. That's really cool. And then the higher end that they were, the more proud they were to tell you, like, I have vodka every day. And you're like, all right, dude, that's kind of strange. And he's like, no, it's what I watch my TV on. And you're like, oh. So I thought that was fascinating for me. As like, it really endeared me to Audioquest, because the end user became really excited to, like, this pride of ownership I hadn't experienced in cables before.
Yeah, yeah, it's very cool.
There's another aspect to this too. I can't speak for our founder, Bill Low. I can assure you all of these names are his or his significant other. And the reason for this is because this is something that he loves to do, really prides himself on. And I don't think he'd be hurt by the comment, but I think, and I can't answer for him, but I will do my best to paraphrase, and I will try to channel Bill Low, and I will fail, but I'll do my best here. And it's the idea that, as Isaac alluded to with aspirational audio and being the ambassador, another title that comes from Bill. So here's the thing. I am an unapologetic snob, always have. And so for me, it's when I first arrived at Audioquest over 8 years ago, it would have been signature all around. Now it's Dragon, and the Dragons are my designs, and I'm pleased as can be with them. But what I've always known, every place I've ever worked, it doesn't matter if it's Audioquest or any of the scores of places that I have worked and toiled and invented before that. Where we had much more familiar names, and there was a number hierarchy and there was a letter hierarchy. There was far, far fewer things to choose from. So it made it much easier for you and me. Because Adrian, I'm with you. If I don't have a catalog on my desk, I'm done. And to this day, don't ask me what anything costs. I'll be wrong. But here's the thing. We value and honor that customer, and not just from a service standpoint or giving them a good product, but from the standpoint that we honor that aspirational element, in this relationship with us. We want the customer that purchases Forest or Cinnamon to be as proud, of their purchase as the one that would buy Thunderbird or Dragon. So when you have those names that don't necessarily give away this idea that you've arrived here and everything below that is somewhat below or also ran. It helps with that. So it's a blessing and a curse, because to a certain degree, where is this in the line? I got to look this up. That does occur, but on the other hand, you never have this, like sense that somehow or another what you're, purchasing isn't for your value system, for your budget, the best it could possibly be.
Great answer. So that leads perfectly into what I wanted to discuss with you, Garth, today. Um, um, so I first met you many years ago at the Winter CES in Las Vegas. There was a press release saying, come see our new lineup power conditioners. Well, at the time it was just basically the one. And we're going to be demoing against some of the most well-known power conditioners. So I was really intrigued by that. Because in the past, with very few exceptions, most of the power conditioners that I tried, I didn't like the results of. Overall, there were benefits, but there were a lot of also negatives. And I had actually owned a Shinyata, and for the life of me, just before the thing, I couldn't remember what it's called, but it was the same one that you used. Anyway, I'm jumping ahead. So I get into the suite, right? And you're there right in the middle with, I think it was Vandersteen speakers, and and on the left side of the wall and on the right side of the wall, on the floor, altogether must have been about 8 or 10 competitors' power conditions. And they were all well-known ones. And I saw and spotted the Shinyata, and I thought, wow, these guys aren't kidding. They're actually there to demo, or at least seemingly demo theirs against, the big boys. So you were playing some stuff, and when I walked in, through what was to be then called the Niagara 7000. And then afterwards, he said, okay, who wants to hear a comparison? And everybody said, yes. And then you asked, okay, which one do you want me to compare it to? And virtually everybody said the Shinyata. And it was funny because I guess everybody had either heard of or had experience with or knew about Shinyata's very well-known reputation, and deservedly so, for their power conditioner. And I thought, well, this will be interesting, because Shinyata at the time was definitely one of the top. So you proceeded to do a comparison A-B, and I was stunned. I honestly thought, my God, this thing is incredible. And I didn't expect that. I really thought, yeah, there'll be some pros and cons. They'll both be pretty good. But to my ear, and considering the fact that I actually owned the Shinyata, I was really impressed by the Niagara, and that it was still a prototype. So fast forward shortly afterwards, I think 2-3 months later, Fred says, hey, want to go to California? I said, sure, sign me up. So we flew down to the factory. And it was funny because if Fred remembers, we missed the connecting flight. Yeah. We were running from one gate to the other gate, trying to catch the flight. We completely missed it. So Fred and the boys from Montreal, there were a couple other dealers from Montreal, they all said, okay, well, let's go hang out. So we went to the bar, and the boys proceeded to get drunk, like totally drunk. Fred won't admit it, but he was totally drunk, and so were the boys from Montreal. Anyway, we got in, and then we took a tour, and that's when we met Garth. And so Garth, tell me about how did you come about with Audioquest? What was the company that you were previously working for before you joined Audioquest?
Other than a lot of ghost engineering that I did part-time through a lot of those years, I had a 16-year run with a company called Furman Sound. Now, Furman is somewhat known in the custom install and two-channel industry, but not too terribly much. What it's really known for is pro audio, music industry, and professional broadcast. That's where they have been. They started their careers with some signal processing for musicians, essentially taking studio grade equalizers and things like that and making them rack mountable. That was something that didn't exist before they did it in the mid to late 70s. But what they became known for by about 1986 to present is their AC power products, power conditioners, regulators, distribution, you name it. And in that particular environment, performance matters. But what mattered more was this can't fail under the most, arduous circumstances. It just has to be a rock. You're doing live sound for, 200,000 people, show must go on, can't fail, no excuses. So that's what we learned to do. That's what we cut our teeth on. Of those 16 years, the last 12, I was the lead design engineer. And I designed many of the broadcast and pro audio pieces, certainly not all. It was a very mature and wide product range, but I also started our custom install and home division. And those were entirely my designs. And so it was a situation where the first time I met Bill Low, they were actually considering rebranding or rebadging Furman designs. But before that could happen, Bill Low had actually asked at the time one of his vice presidents, and his essentially what I call Bill's ears for God. I mean, at least 25 years of a 30-year run was Joe Harley, who's now head of music, basically doing the sound and helping with the mastering and everything like that for Blue Note. Before that, Music Matters. But anyway, it was a situation where the job was bring in every power conditioner known to man. It didn't matter if it was built by two people in someone's garage, bring it in. The Furman had been one of the, IT Reference at the time had been one of the few that they liked. As you talked about, Adrian, most of them they disliked. That was one where they just couldn't find any deficits, and they were almost all positives. So they brought us in, and but that had mostly been Joe Harley that had done most of the work and had the enthusiasm and said, bring these guys in, this will be interesting. Bill still really wasn't sure because all of his early experiences had been incredibly disappointing with power gear. He was plugging directly into the wall or into just a basic, hauled out strip with just good wiring. That was it. And that was his favorite. And I remember him walking into the meeting after all the vice presidents and all the sales teams were busy, exchanging jokes and shaking hands and talking about how much money was going to be made. And he came and just threw a wet blanket on the whole thing. His opening salvo was, why do I even care about this? If this is AC power products, this is just packaged fear, surge protection. Why do I even care about this? These things make everything sound worse. And all of a sudden, all these very loud, boisterous, sales teams and everything and managers just went silent, numb. Oh my God, our deal's about to, go down. And, I just looked at Bill and said, well, you're right. They don't work. Would you like to know why? And I spent the next 10 minutes explaining precisely why, and then explaining, here's why we're different. Here's how it could have been done if you knew what the problems were. And then for 9 years after that, I had essentially a ongoing invitation to join the team when I was ready. But I was living in Northern California. I'm fiercely loyal to whoever I work for, and I thank them profusely at the time, but I had no interest in leaving. Also, professional jazz musician when I'm not wearing my engineering cap, and I was just ensconced in the northern Bay Area of California music scene. Well, things changed. It's that old thing where your corporation gets sold and then sold again and sold again. Eventually it gets to the point where it becomes something you don't recognize. And I just kind of realized, no, I need to make a change. I've always been curious about this. I started as an audiophile from the time I was 15 years old. I'd really like to get back to this and not just be at the edge or tinker around the edges of that. And so glad that I did. We're really busy. It's a hard job, but I'm a kid in a candy store. We get the permission to make the best products we possibly can. And although it seems like that would be true everywhere you work, believe me, it's not.
So let me just step one step backward. I remember when I first met you at AudioQuest, and one of the things that I was shocked to learn, which you glossed over a little bit, was that in the broadcast world, Furman accounts for, what is it, 80 or 90% of
Oh,
the power protection business?
98.
98.
No, they own that category.
So all the broadcast companies like CBS, ABC, CNN, et cetera, all essentially depend on Furman.
In their racks, yeah.
Yeah, wow, that's unbelievable. Yeah. So in other words, it's fair to say that you have a little bit of knowledge and experience about power.
Yeah.
Some of your favorite rock concert venues are powered by this stuff. That's what got to me, is I learned about Garth years ago when I was going to shows and found out that this stuff was powering, multi-1,000-watt line arrays. It's what made the music happen.
Yeah, very cool.
Yeah,
so,
that's where you learn to be bulletproof. That's where you learn to measure. That's where you really cut your teeth on the science of this. This is not pseudoscience. This is not guess. This is not theorize. This is prove it, buddy, engineering, because the people I worked with were not audiophiles. I was the only one in the building, and I got hell for it from the other engineers. Because a lot of people in the audiophile world and 2-channel don't know this, but pro audio, they hate us. They can't understand why they're toiling so hard and their market's so small and they're making so little money. And they look at 2-channel enviously with, like, how can this stuff sell for this money? How can people be purchasing it and everything like that? And then they read the ad copy and and because it's a different customer that you're trying to reach by different means, and it doesn't read like something that you would advertise to broadcast, where you've got the architectural specifications, and everything's by numbers. Well, Adrian, in our world, you can't do that. An engineer might love you to do that, but as I'm famous for telling people, engineers don't buy anything. We make it ourselves.
Yeah.
And that's the last customer that you want to please.
Yes.
So it's really a situation where that's what you learn. But what I also learned while I was there is that these people were famous for believing in their $250,000 to $1 million laboratories and never listening to anything. And I was the heretic that when I really started doing serious work, started listening to everything, and therefore learning new technologies and changing the way we were measuring. Still believe in doing both to this day, but you have to sit there and have a conscious decision about what's the application? Who is this for? Am I making this for a laboratory? Am I making this for someone who's going to listen to their system or watch their system? Because if it's the latter, then I have to have that as part of every one of my tests. Because if I'm looking at a spectrum analyzer and I'm seeing 5 problems that I need to fix in my circuit, which of those 5, and I can't fix all 5, which of the 5 is the worst? Is it the one that has the highest peak? Maybe. That would certainly make sense. That's certainly what anybody ever worked for in those days would have done. The problem is when you listen, you might figure out that the smallest or the second to smallest one is actually the most objectionable. And we may have to learn to measure a different way to be able to determine that it's actually a bigger problem than you're seeing on the lab instrument.
So let's talk about the Niagara 7000 specifically. When you came out with that, what were the technologies that you were trying to use within the 7000 and why?
Every technology in a Niagara product, whether it's our flagship 7000 or the 1200, 3000, or 5000, other than the fact that every year there are passive and active parts that sometimes get better and more refined as new technologies are made available to us, there isn't really a single technology that I'm doing that can't be traced back to the 1920s. AC power is late 19th century. And really, there is nothing new under the sun. It's application and putting the right ideas in the right place, going for the best average. I never want to know specifically what was done to a circuit. I want to know why it was done. Why is infinitely more important. It's understanding what the problem is, because it's so often the case that you can have a patent, and we've got patents on the 7000 and other things that I've done, sure, but whether you have them or not, to me is irrelevant. It really comes down to, you can basically come up with a very exciting new technology or a new discovery, and then you can take that success that you had in one area of an audio circuit or your overall practice, and then you can think, you know what, damn it, that worked so well. I'm just going to, this is going to be like, like a machine gun. I am just going to spray this technology over the walls. I'm going to put this everywhere I possibly can. The world's got to know this idea is just so damn good. Problem is that it might have been really good in the original application you put it in. It may be mediocre in the second application. In the third application, it may be a disaster. What's really important is not, like that I use symmetrical power here in the 7000, or that I dielectric biased it and got a patent. It's not the ground noise dissipation that we got the patent on as well. It's not the proprietary capacitors and the fact that we burn them in on very expensive machines for 24 hours to completely form them and lower their distortion. It's not the directional wiring that's inside. It's not the linearization we do in the filters. It's not the grip of the outlets that have 40%, like more mass and metal than any other outlet that's ever been, like made like that before, or the kind of plating that we employ. I can go on and on and on with the bullet points. But believe you me, if you get any one of those things wrong, and 100 things I didn't mention, the whole thing can fall apart. It's the care and detail. It's the fact that I am listening as well as looking at the measurements with absolutely every crack and crevice of something like this. When I'm developing a product like this, no stone is unturned. Everyone says it, but you need to back it up. And the science needs to be there too. That'll keep you from chasing your tail, because you can have the best golden ears, you can be a musician, you can know precisely what Hamburg Steinway versus a vintage New York Steinway from the 30s sounds like, and I could absolutely hear every little detail. You could have that ability. But if out of 30 details in your product, you have accidentally, without realizing it, made a mistake on just one or two of them, you can sit there and tune by ear all day long for weeks and eventually come up with something pretty good. But it's got trade-offs and you're not really quite sure about this. If you had started with proper tests, you would have seen, oh God, there's two problems here, that the math didn't come out like we thought. Fix this, fix this. Now I'm starting from a point of truth, but I'm still at a B minus. To get an A plus, that's this. Got to hear it.
So in the world of power conditions, at least in the audio world, you see companies that use, for example, some form of isolation transformers, sometimes for other times not, coupled with surge protection devices like MOVs and so on. And then, of course, you have a company that's completely attacking it differently, like PS Audio with their Regeneration system. What are your thoughts about all of those different technologies, and why or why not go those routes for you?
Well, my first thought about all of that, and this is the one thing where you were one of the very few people that ever got to hear a comparison of our so-called competitors like that at a trade show We did that for 6 months and never did it again. And I felt embarrassed to do it. And we'd always have a lot of there, so it never felt like we were picking on any one manufacturer. We always gave people the option, because we did that at first because we needed to demonstrate that we had earned the right to get people's attention and to have their business. We needed the credibility. After that, we've never done it again since, because I truly believe, first off, that none of those companies are real competitors. Our real competitor is a wall outlet and a $25 strip, because that's still 95% at least of everyone that's got an audio or video system, unfortunately, still to this day. And everybody else fighting over crumbs when that big of a piece of the pie is left. No, the real job is not beating up amongst ourselves. It's getting people like Fred and Isaac to educate the world, because I can't do this alone. You can't do this alone, Adrian. We all have to work together. And if we all work together, and if we do this right, all boats will rise. We will all do better. That's the first part. So the second thing is that, again, it always comes down to application. Let's take Regeneration. This is the idea where you're building an amplifier, but it's a power amplifier, but instead of being a power amplifier for audio frequencies, it's a power amplifier for one frequency, 60 Hertz in North America, 120 volts out. So if you need a voltage regulator, that's as good as it's ever going to get. But the thing is that most of our equipment does not. It's got direct current DC regulation inside its power supplies for most of the critical circuits. So that's usually redundant to begin with. And it's also fabulous for getting rid of any level of harmonic distortion. There are times that that's incredibly useful, but for the most part, it's not, because any component other than an AC synchronous motor and a turntable without a outboard power supply, that's the one exception. But for everything else, it's about to go into a power supply through the AC cord that's going to turn alternating current into DC current. Once it does that, your 2 to 4%, sometimes double-digit harmonic distortion goes down to 0. So it's a direct current at that point, similar to a battery. So that's not necessarily helping you too much. Is it better than the wall? In many cases, yes, it would be. In some, maybe not. Because here's that thing that you were talking about right at the beginning. You got to look at the application. First of all, are you going into a power amplifier? Well, if you are, power amplifiers have something that's very unique amongst anything else in an audio video system, and that's that it's the only component where the power supply is not drawing a constant current. It's drawing a variable current. And that's a problem, because even fairly modest power amplifiers, integrateds and receivers, can end up drawing very, very briefly, 10 to 15 milliseconds, a blink of an eye, a transient current draw from your wall that could be anywhere from 30 amps up to 80 amps peak. Just, like, again, for just a very brief period. So the problem when you go through a power amplifier feeding a power amplifier is that it behaves like an amplifier. What do all amplifiers do when you push them too hard? They clip, they distort. Everyone knows this. All of a sudden, that perfect sine wave that regulator can, or that regenerator can create under ideal conditions, say it's a 10 amp, like a regenerator, okay, the sine wave looks virtually textbook. Beautiful. Right out of engineering school, that's what I would have gone to. But what I know better now, because we made things like this when I was at Furman, is that as soon as you hit 1.414 times the fundamental, approximately 41% greater than that, about 14 amps, it's going to start clipping. At 20 amps, that sine wave doesn't look good at all. By 30 amps, your wall looks better. It's current compressing. Strike one. The second issue is that what do all amplifiers have in common? They have a frequency response. They're all going to be different, but that's its bandwidth. Let's be generous and say a power amplifier has a bandwidth of 1 hertz or 0 hertz up to, let's say 500 kilohertz. That would be pretty wide by most standards. I've seen a few things that go up to a megahertz, but it's rare. Okay. What happens, just like an active RAAA stage in a phono preamplifier, what happens when you run out of frequency response or bandwidth? Your filtering's gone. You've just gone from over 100 dB of noise reduction, boom, to 0. You're going to have ringing properties that you're going to be, because that's nonlinear, uneven. You're going to have ringing properties that you're going to hear for 5 octaves below that. And right at the frequencies where induced radio frequency noise are the worst is where that idea stops working. It's not that there isn't noise below that, there is. And that technology will do a splendid job of dealing with those noises. But the thing is, there's over 23 octaves of noise that exists on an AC line and also bombard it, like as an antenna from radio frequencies. I don't want to say that I know the magical frequencies that matter. There is no such thing. These all turn into noise that masks for low-level detail. I want to get them all. Can I get them all? If I can't, I want to get as close as I can to it. And I'm willing to have lower noise reduction or dissipation numbers if I can get that noise dissipation or reduction to be as even or linear as possible. That's critical because I don't want at one set of audio frequencies a result where my low-level detail is unveiled and unmasked almost perfectly at 1 octave from here to here, only for a quarter octave away, I'm only 10 dB down, and I've gone from here to here, and then I've got a noise peak that my technology has created under real world, in what are called impedance conditions, and I'm actually adding 6 dB of noise. And for, for all the octaves of audio, I'm literally going from here to here. It's discordant. It sounds wrong. It's, once again, back to what you said before, Adrian. It's the idea that, well, I like some things about this, but there's other things I'm not real sure about. I need a consistent result every time. And to do that, I've got to understand what my real world load impedances are going to be. And we got to deal with this. You can't deal with this effectively with something like regeneration. It'll have some good points, but it's going to have some whopper and some doozies of negatives. And, again, then you get into some other things like, well, I'm going to run an isolation transformer for everything. I love isolation transformers when they're done properly. When I understand that of the 3 types of noise, it's going to do a fabulous job at one of them, common mode, symmetrical noise. Asymmetrical noise, not so good. Ground noise, it's not going to do a damn thing. And it's also going to have another problem. That isolation transformer could be the size of the rooms we're sitting in, and it would still current compress an amplifier because it is an inductive device. Where current transits are concerned, you're moving the opposite direction that you want to be. So in a Niagara, even though a 7000 has 2 intensely expensive isolation transformers, they are for the constant current source components only. A net power amplifier never goes through them. Again, it's understanding what the application is and what's the best tool, what's the best technology I can throw at it. Every one of these competitors, I can show you the negatives, but I can also show you the positives. One of the reasons we bring them all in is I reverse engineer every single one of them. I love my so-called competitors. I learn from them. I get inspired by them. I'm not necessarily going to copy them, but sometimes just, again, it's the why they did it. And looking at somebody's work and going, that was a really good idea right there. Okay, ultimately, I would do the entire product differently, but, that was really clever. Oh, they were probably listening to this. They were probably looking at this effect, and that probably led to this. All those things are something that if you have dedicated your life to this practice of this type of engineering, that's your food.
Oh, and it's something, Garth, that I learned when talking to you was Didn't realize that, but you said it before. Power was invented over 100 years ago, and nowhere at that time people were thinking of high-end hi-fi system and 4K TVs and game consoles that can do 120 frames a second. It was meant to power a light bulb, right? The power light bulb what we have in our house is perfect, but not for what we're doing. So when you said everybody's trying to fix it, then great, we just have our solution. And like you said, it's using the right tool at the right place. I think throughout the Audioquest lineup and every new product you've built, it's the right recipe, the right ingredients, but execution is important as well, right? You may be a better chef or a better musician than I am. I can play the same notes, but it's how you do it that's important. And that really what opened my mind when we looked at these products. What would be cool to talk about is what led you to build the 7000 the way you built it, right? Why do we have 4 high current and then 2 isolation transformers and those little details?
Well, there's so many little details. It almost kind of like helps to break each one of them down because each one of them you can spend some time with.
Right.
But again, it's sort of like, okay, well, again, look at your application. What are you trying to do? Well, one of the things I have to find is what's in the system. I know in my 2-channel system, I'm going to have at least a stereo amplifier. I might have some monoblocks. I might have some subwoofer amplifiers.
Right.
I might be bi-amping. So I have to look at, okay, depending on the expense of the Niagara and therefore the likely, accumulative expense of the system, it's likely to be paired with. Mm-hmm. How am I going to deal with this? How many high current outlets am I going to need? And by high current, what's usually meant by that in the power game is, these are the ones that are made for a power amplifier, or sometimes they'll say whatever is your, your high current devices. But really, a more sophisticated way of looking at that is just power amplifiers, because, the RMS draw on a small AVR or integrated, on average, might only be 2 amps. I can show you projectors. I can show you flat screens that are drawing more than that on average. But that flat screen and that projector, once they draw that 3 amps or that 5 amps, it'll never move once it's in conduction. Again, that power amplifier will be many times its fundamental for audio transients. And you don't have to be listening to ear-splitting levels. Everything's doing that because as great as loudspeakers are, they're relatively inefficient. So you're always at the edge of your power, assuming you don't have, a recording that's kind of compressed and slam limited. But anything that sounds natural, you've got a lot of dynamic range to contend with. So for high current, one of the things that we have is something in our 3000, 5000, and 7000 Niagara, transit power correction. And this is a technology that is borrowed from power factor correction. That goes back to the 1920s. It's still in every major building or every major factory that you've ever seen. What we're doing is a variation on that technology, but it's for the transient only, because the power supply in these amplifiers doesn't have a problem typically with sustained energy or just basic sine tones. If we all promised to only listen to pipe organ music, we're good to go. But if we have anything that goes for a second, like the plectrum, of a string instrument, like the strike of a drum, or the sforzando attack, of a piano, well, that all of a sudden is a peak-to-peak, like a voltage swing that's enormous and very quick. And that's where the best power amplifier power supplies in the world get into trouble, not because they didn't care, not because they didn't put a lot of work into them, but because all the emphasis is at direct current, like a battery, the DC part of the equation. We're bolstering the AC part of the equation that's feeding it. It's balance. You have to get both.
Right.
And we give it, like anywhere from 55 amps peak up to 90 amps peak of current reservoir up to 25 milliseconds, more than enough to get through the transient peak, be a buffer, electrical buffer stage, and essentially make that power supply in the amplifier as efficient as it can be. Then the source outlets, do you treat it the same way you treat your high current? No, you don't, because again, they're not the same devices. This is a current where the device comes on and then after a second or so, it stabilizes. I have to treat it differently. But let's say I have a system where I'm playing vinyl. What's likely today if I'm playing vinyl? Well, there's certain things we can assume, but one of them is there's a real good chance if it's a premium system, I've got a low output moving coil cartridge. What does that mean? That means that my phono preamplifier is 65 to 70 decibels of like a signal gain. In order to get to line level to my amplifier, then that's going to bring it up another 20. So let's say that that vinyl recording has 70 to 80 dB of dynamic range possible. They did absolutely everything right as best they know how to do it. If you start taking these numbers and you work backwards, what you realize is that not just the cartridge, that entire audio system that you're playing your vinyl through with your low output moving cartridge that you love so dearly and paid so much money for, that system needs to be absolutely squeaky clean at a microvolt to not distort or nerf with noise all those harmonics and low level details. Would anyone care to guess how many systems in this world, regardless of price, multi-millions of dollars invested, are squeaky clean at a microvolt? Not one. And it'll never happen in my lifetime. I can guarantee you that's nearly impossible. So power being one part only of that equation is one more area where everything we can throw at that system to unveil that information that's sitting in those grooves, we got to do. The problem is not quite so hard for digital, but it's still a similar situation. The lower the level, the more we've got to do to take care of noise. You know, so many people make the mistake of assuming that noise means in the background, or like white noise in the background, or breaker 1, 2, or your local FM station breaking through a system. If your system is decent, no, those aren't the real problems. The problem with these types of noises is they're insidious. This is a noise you don't even know is there until you hear the effect of stripping it away, unveiling, getting rid of the mask, from this to this. That's what we're really dealing with there. And then in terms of just, that's the big difference in terms of like how you honor and treat a source component versus a high current component. And depending on the Niagara and the kind of system it's going to go with, you'll have, as you move up the line, more high current outlets and more source outlets, because on the bigger system, I have more demands that way. I have a smaller, more modest system. I don't need as many outlets. I would love to throw the technology that's inside a 7000 into a 1200. I can't do that. It would be nearly 100 pounds. It would be out of many people's price range. And it's even more space than some people will have for a modest system. Again, right tool into the right system, the right place. But the common thread through all these things is honor what the system's going to be and make sure that all of the things that you're affecting, the unmasking, the unveiling, is as even and linear and consistent as it possibly can be, given the restrictions of size and cost.
Before we leave the subject of power, because I know I want to cover a couple other things as well. One of the things that I was fascinated by, which you also glossed over earlier, but you talked about it when we met in California, was that as part of this white paper, start from scratch design of the Niagara 7000, you guys came up with a solution of bedding in or breaking in the capacitors. And in order to do that, you custom ordered this machine to do so. And this machine is made for you by some aerospace company. Can you talk about that just a little bit?
Yeah. Let's see. As I recall correctly, so we just had to order a couple more. Those are Amatec 1501s eyes. It just is this big gray or kind of like mauve, ugly box, like with fans to keep it cool. And all it is again, it's very much like an AC regenerator, except that we can program in the frequency and we can program in the voltage, specifically around the capacitors. One of the things that people have known for years and years and years with audio, and it's as true today as it was 10 years ago, 20 years ago, 50 years ago. The longer you leave a new product on, the better it starts to sound. Everything seems to settle in. For a long time, back in the valve or tube days, people assumed, well, the tubes look, like it's got to come up to temperature, it's got to settle in. You can watch the bias kind of moving around. It'll kind of move around for 30 minutes or something like that. So people kind of understood that. Then when we got, immersed into the transistor age, the assumption was, well, they perform more linearly, the output devices do, once they get fully up to temperature. So this is going to take a certain amount of time. But eventually people realize, well, wait a minute, we're hearing this effect on preamplifiers and things like that that run ice cold their entire lives. Well, eventually people started realizing in the 1970s that no, you've got a lot of passive parts as well as active parts, and capacitors being one of the main culprits, their characteristics, their what's called their Q, would change with frequency a little bit as they were used more, so-called run-in or broken in. They would definitely get better as the months went on. So many people have talked about, oh, this piece brand new out of the box, it sounds bright, or it sounds like choked, or it sounds constipated, or it sounds veiled. And then all of a sudden, like 2 weeks later, 1 month later, worst case 2 months later, oh my God, this thing's glorious. The sound stage has opened up, everything's fine. One of the many, these are electromechanical devices. It's no different than taking your new sports car literally right off the factory floor, out to, a race course and trying to full throttle it right off that course. Bad idea. You got to break it in. It's a mechanical device. Well, electromechanical devices, it's miniaturization of that process, but a lot of the same things apply. So capacitors was something that people have known for years, particularly other engineers, that these are one of the devices that kind of need to be broken in. But the thing is that what I knew from being fortunate enough to have met some of the engineers that were involved in making the film capacitors for our space program during the Apollo missions, component research being, one of the main culprits. Jet Propulsion's laboratory and NASA had figured this out in the late 60s. And it was basically the idea that whatever the, not direct current, but whatever the maximum AC voltage, withstand was for that capacitor, if you broke it in for 24 to 48 hours, at full AC voltage potential, at high frequency, it would stabilize. And that was important in the late 60s and early 70s because the kind of circuitry and precision we take for granted now that's inside our smartphones in those days was a massive panel of analog parts, and they had to be perfect. We have invested at this point probably about $60,000 to $70,000 in 4 of these machines, where we are fully forming every capacitor that goes into every Niagara every single day. I have people that help me do it in Irvine. I've even lately, because we're shorthanded, I've been coming in on the weekends and collecting some of these things and emptying the trays. We're that busy. But I'm willing to do it. I'm happy to do it because it makes so much difference.
Cool.
And that's just one teeny aspect of what makes these things unique. Another thing that we do, you didn't ask, but it's just as important. As with Audioquest cable, every piece of hookup wire inside a Niagara has solid conductor that's directionally oriented. I've shown this to people that come to visit. You can hear 3 inches of solid conductor when it's, grain orientation is going in the more linear path versus the bad or non-linear path. It's just high frequency versus resistance, an induced noise being radio frequency noise. Kirchhoff's law follows the path of least resistance. All right. So the thing is that if you can hear 3 inches, what I try to explain to people is inside a Niagara 7,000 or 5,000, you have anywhere from 50 to 60 feet of wiring inside that thing. If you add every junction together, all the line, neutral, and ground, so if you don't even know to do this, if you don't have the personnel to do this, if you don't have the means of testing for this, it's not that you won't have a good unit that has a lot of admirable qualities, you will, but it can't be this linear. It can't be this good. It can't get a lot of that stuff off the floor. It can't drain as efficiently. It's like a gutter system that's got leaves, rocks, and dirt in it. Particularly at ground, which we've got the ground noise dissipation with the patent for. So when you start to look at things like this, and that has to be part of that measuring, for all those, for every single roll or reel of wire, that's done by me. I go into our sound room on our top system. I have a bunch of, the 3 to 5 inch, leads, they're pre-trimmed. I'm grading every one of them. I've got the same system, same setup, same place that I, stand, same recording, that's same volume every single time. And I would love to not have to do this because it's really getting tedious, but it's so worth doing because just like the capacitors, it really, really makes a huge difference. So again, it's the little things as much as the big things. We can talk about the big ticket items all day long, but one of the things at trade shows and so forth, I never get the opportunity to do is explain to people that for everything that you see, on the bullet point, or the 2 or 3 things that get driven home when you've only got 5 minutes with a customer, there's 100 things you don't even know about. Nothing's been overlooked. Nothing.
That's always what impressed me talking to you, Garth and Bill, and everybody at Audioquest is the attention to details. And that's what makes every product special and makes my life and Isaac's life busy because we have to convey that to guys like